Hello, I am Channa Bankapur. I'm a trainer at Master Technologies, and this video is being made for the YouTube channel of Master Technologies. Please do subscribe to it. Today's problem in September LeetCoding challenge is out, and today is the last day of September. I have solved it, and I want to discuss my solution with you. So the problem is we have an unsorted array of integers, and we need to find the smallest missing positive integer. So if you go with these simple examples, in the first example, among the positive integers, 1 and 2 are present, so 3 is the smallest one. And in the second example, 1 is present, but 2 is not present, so 2 is the answer. In the third one, 1 itself is not present, so that is the smallest positive integer, right? So let's see how to do it. Let's take the second example, which is kind of good. So if I can have another array of same size, say 4, and so let's index them with one based indexing for easy understanding, because we are expecting elements in the range of 1 to n, right? So let's see if these elements can be placed in their intended place. So 3 is going to go to 3, and then 4 is going to go to 4, and -1 is not valid, so skip that, and 1 goes to 1. So the first place which is not filled with a proper value is 2. So that's why 2 is the answer. What if instead of -1, if it were 2, then we would have 2 also. So in that case, all the elements from 1 to n are present. So that's why the answer is going to be 5, right? Which is the smallest positive integer. So any integers which are outside of the range, which if it is less than 1 or and greater than n, so they're all kind of invalid and we can skip them, right? And they are going to kind of create holes in this kind of array we are going to construct, right? It works in linear time clearly, and also it takes extra linear space. But what they are kind of asking here, can we do it with constant extra space? So how can we do it without even using this extra auxiliary array? Okay, I'm thinking of how about transforming the input array into this something like this, right? In that case, um, we can answer the same thing, right? So once we can transfer it that way, right? Here is what I'm thinking. So the same array is going to be look like we already have an array which has 3, 4, -1, and 1. So I'm going to index with 1, 2, 3, 4 again. So let's see if I can move these elements to their intended places, right? So look at 3, and 3 should be at position 3. So I can go and then write at 3 position. -1 is anyway not we don't care about that. So we placed it. Obviously, I need to destroy this 3 because otherwise it will be confusing. Maybe I'm going to destroy this and then mark it as 0. 0 is anyway outside of the range of 1 to 4. It's okay. And at position 2, we have 4, so I'm going to move it to 4. But when you move that to position 4, we have an element 1 there that should not be destroyed, or you should not be overwriting that directly. So save that elsewhere and then move that 1 to some other place, which is its own intended place. So when you move 4 to here, obviously I'm resetting this 4 to 0. And now this 1 should be moved to this position 1, so it will come to this position. So 0 is overwritten by 1. So that's how I have a resulting array 1, 0, 3, 4, and you can figure out the first invalid value is 0, which is at position 2. So 2 is the answer, right? So this should answer, or maybe this should work. Let me take a little more elaborative example so that we have understood the idea properly. I'll take a little longer example, maybe having some 8, 9 elements. I'll take 8 elements. So suppose we have, I'll still use the one based index here, right? So we have suppose -10 here, which is not going to be touched, and suppose we have 2 here, which is in its place, and then suppose at position 3 we have 8, and at position 8 suppose we have 5, and at 5 we have 3. So this kind of makes a cycle. And at position 4, suppose we have 7, at 7 we have 4, so that's a cycle of 2 elements. And suppose 6 is present at 6, that is also kind of cycle of length 1. So we figured out, as in we got an example here. how to figure out which is this smallest positive integer that is missing. Figure it as in try to transform that and then figure it out how to do it. So I'll start with the first one, and I'll make sure every element at every place we are going to have the intended element there, or we are going to have some kind of zero or something like that, which indicates we don't have any element there. So so what we can do is we'll see this position one. It says it says minus 10 here. So I can just leave it there, right? I can set it to 0, but I'm going to leave it there. And then I look at 2, and at 2 also we have the intended element already, so there is nothing to do. I'm going to go to 3. So now I is equal to 3 here. I look at here, and then there is 8. So I want to move to some other places, and it's in its place, which is 8. So, but there is other element I want to move to that. So it looks like there is a cycle there. So we want to make sure we complete the cycle. So what I'm going to do is I'll use some kind of variables. Suppose I'm going to save this item at 8, and which tries to move so that I can destroy this and reset it to 0, right? So that the cycle has to end, right? Otherwise, if 8 is there, it doesn't look like cycle is ending. I have 8, but 8 cannot be directly overwritten on position 8 because there is other element. So I'm going to store that in some temporary variable, say 5, and then I'm going to overwrite this place with 8. So 5 is saved anyway, it is good, right? So we did one step, but yeah, we need to do this in a cycle. So now look at this 5. 5 needs to be moved to its place. So to continue that, I'm going to remember 5 as the new item, and 5, I look at 5, and then there is other elements. So I'm going to save that here as 3, and then I destroy that, and then write 5 there. So and again 3 I'm going to remember as item so that I keep continuing. I go to 3. So what I'm going to do is at position 3, I remember 0 as the new temporary variable, and I write 3 at this place, and then I copy this 0 to item. So now when I see item as 0, I don't have anything to do because it's kind of completed this cycle, right? Either it has completed the cycle, or we have ended up to a place where there was some out of range element, so we don't have a cycle to continue. So this is how my cycle ends. And now look at this 3, 5, and 8 are in its places already. And now I continue my I to 4, I equal to 4. That is also not in its place. So I'm going to continue the same idea. 4 is the 7 is going to be moved to its place, and then 4 is going to be moved to its place, right? We can think of the same item temp cycle, which is going to do the job. And then when I equal to 5, it is proper. 6 is also done. 7 is done. 8 is done. So we are done, right? And once we have this array, you just scan it from the beginning. So the first element itself is not the intended element. So that 1 is the answer. But what if we had 1 here, right? What if we had 1 here instead of 10? The answer would have been, if you look at here, 1, 2, 3, 4, 5, 6, 7, 8, all of them are there. So the answer is going to be 9 in that case, right? But what if, suppose instead of 6, we have 0 there? Then we see this array 1, 2, 3, 4, 5, 6. At 6 we have 0, so the answer is going to be 6, right? So these are the maybe 3 test cases I want to test out. The respective answers are going to be 196. Let's quickly go to coding. I think this already kind of illustrates why it works in linear time, but yeah, let's see that analysis maybe towards the end. Right, so here is my code. I want to keep that example there and then work on that. For convenience, I'm going to use n as the size of the array, which is nums dot size, instead of keep typing that every time. So what I'm going to do is I'll just go through each element. I'm using one based index here. Let me use the same thing. But whenever I'm accessing the array nums, I'm going to reduce one value so that it becomes automatically zero based index. So only when I'm accessing an array, I'm using zero based index, but for everything else, it is one based. So I is less than or equal to n is what we want to go with. Uh, so this is going to make sure at this ith position, the element I is going to be there eventually, or if at all, if it is there in the array, otherwise some other out of range value. So if it is already I is the ith element is there in I element is there in ith place, or if it is out of range element, we don't have to do anything, right? Only if it is kind of not equal to I. So that means if nums of I minus 1, Why I minus 1? Because it's zero based index. If it is not equal to I, this is one condition, and another one is it should be in the range. So how do I check it's in the range? There are two things I should check. One is if nums of I minus 1 is greater than or equal to 1, and nums of I minus 1 is lesser than or equal to n. So this indicates this is a valid element which is in the range, but it is not in its place, so it needs to be moved to its place. So how do we move that? We already discussed the idea. I'm going to save this element in item, so nums of I minus 1, so that I can reset nums of I minus 1 to some invalid value like 0. 0 is not in a range of 1 to n, right? I'll save that, and then I go through a loop, which is a cycle, which is going to reset all of these things in cycle, right? So what should be that cycle again? The condition is should be same as pretty much this, except instead of I, it is going to be the item we are dealing with, right? So let me just do this one. So the first thing is if nums of item minus 1 is not equal to item, that is the first condition, and nums of item minus 1 is in the range of 1 to n, right? This is what we want, right? If that is the case, we want to, in every iteration we want to move that item to its place, and yeah, so let's do that first. So I'm going to save whatever is in nums of item minus 1 uh, into a temp variable, so that I can write on top of it, right? Nums of item minus 1 is going to be item, so that is now set. But now in the next cycle, whatever is temp needs to be carried forward to its place, right? So that's why I'm going to copy that temp to item and then continue the cycle. So this should continue the cycle. We already discussed that cycle of I think 358. That is going to work this way, right? Let's see what else we are missing here. I think nums of item minus 1. Okay, this is going to be, no, this is not the, okay, we need to directly check if item itself is in the range. So item is in the range. This is what we need to check. And also if item is in the range, and this one, okay, this could be a problem if it is not in the range, right? So this is going to be a runtime error. So I'm going to check this condition later, so that, you know, if it is in the range, then only I'm going to access that element, right? This is good enough. I'm going to put parentheses so that, you know, these order of precedence is going to affect us otherwise. So I'll put parentheses around these conditions. All right, similarly I should do here. Let me start from beginning. So if item is greater than or equal to 1 and less than or equal to n, that is essentially it's in the range, and that index also has that item, right? If that is the case, if the index does not have that element, then we can keep continuing the cycle. We say we are okay, we are done here. So this is going to basically transform the array the way we want it, right? In a way it kind of sorts it, but if the element is not present, we have either that out of range element or 0 in specific cases. 0 is also out of range element. So now all I need to do is I need to just go through the same loop and then check the first element which is not in its place, right? So less than or equal to n and I plus plus. So again, I'm using one based index here, so I need to make sure. So uh, if nums of I minus 1, because that nums is zero based index, if it is not equal to I, then we have a problem, and the answer is I, right? So if none of these find the actual I, that means the answer has to be n plus 1. All right, so this should work. Let's quickly run. I hope the example is clear. I'm going to erase the example. So let's run with this test case. Yeah, it worked. Maybe I'm going to go with that example we discussed. Bring back the example. So let me work with that first example, which is going to be like this. Minus 10, then 2, 8, 7, 3, 6, 4, and then 5. right? I think that's good enough. Okay, so let me run this and see whether it also gives the correct answer. Yeah, expected and my answer are both are correct. Let me check whatever I wrote in blue, which is what if the first element is 1, so that there are no missing elements, so the answer has to be 9. Yeah, 9 is the answer. What if some other element is missing, like something like 6 is missing, right? In that case the answer has to be 6, and we got 6, right? So I guess this is good enough to submit. I'm going to submit it. Yes, it accepted, right? And it's pretty good. I think not many people have submitted it, but it ran pretty fast. All right, space wise, it says it takes time. I'd say it takes some space, but I'm not sure how to look at that. Okay, so now the only remaining thing is obviously we are not using extra space other than temporary constant space. Time wise, we can see it takes linear time. The way I'm going to look at this one is, see, this loop runs linear time, right? For loops, and there is a while loop inside here that looks like, okay, we are going to have quadratic time here. But the thing is, so this loop checks every element once for sure, and this loop, whatever the elements that are out of place, they are going to be placed in its own place, right? That's the cycle. If it is already in its place, this cycle is not going to be affected at all. We don't even come inside this if block, right? That means all the elements that are out of its place are going to be moved to its place only once. That is at the max, like n operations. And this condition is going to check for every element exactly once, whether it is out of place or not there. So that is at the max another n operations. So in the worst case, only 2n operations we do it, and that's how this is going to work faster, right? That's how it's going to work in linear time. Right? I think that's good enough. All right, so I hope the solution was understandable. Make sure you try on your own and then execute this one. All right. So yeah, otherwise, yeah, if there are any comments, please let us know. If there is any better way of implementing it, let me know. Or if you want to share your own implementation, please comment, right? And suggestions are always most welcome, right? Please do subscribe to this channel and like the video. Thank you for listening.